Hello everyone, I am Salla Kaushik and today I am here to present a brief about our PRML course project. Our topic is Music Classifier and Recommendation System. So this is the abstract for our project. So we developed a personalized music recommendation system and also music genre classification system. So we did a deep study to improve the effectiveness of both the systems. So this is the overview of our project. So what we propose. So for first we will look for the music genre classification system. For this we use the GTZAM dataset available on Kaggle. So we use the Librosa library of Python to extract the audio features from the audio files. And how it works is that the user inputs an MP3 or wave type file, and the program classifies it into distinct genres. So we use different algorithms which we will see in the coming slides. And for the second part, for the music recommendation system, we scraped the data from the spot using the Spotify API and also extracted audio features from it. So in this, the user inputs a song name and it outputs the songs similar to those. So for the first part, the classifier. So we applied we for the approach we applied these models, and following are the accuracy we got from them, and we can clearly see for the light GBM model we got the accuracy of 90.84%, which is the highest among all. So we did some hyperparameter tuning over it, and in the ending we can see that we got an accuracy of 92.43% for that. So this is the EDA for the classifier model. So on the left we can see the box plot between tempo and label. So we selected the tempo for the box plot because all the other features was divided into two parts, which is the mean and the variance, but tempo was alone. So we use this to plot the box plot to see the spread of the feature and also the outliers around it. And on the right hand side we can see the correlation for the features. This in this part we can see we plot the graph for the PC of the genres and the LD on the genres, and on the for the both we chose the n components as 2.
Hello everyone, my name is Aditya Trivedi. So, we implemented our recommendation system using mainly three techniques. First is the clustering techniques, for which we used KNN. Second is dimensionality reduction techniques, for which we used PCA and TSNE. Third is the metrics, for which we used following similarity matrix techniques, including cosine, Euclidean distance, pairwise, sigmoid kernel, etc. So we used all of these techniques to determine which of the following will be the best for our music recommendation system. In the next slide, we will discuss about it. So here we performed EDA for our dataset, and for determining the best optimal K value for our KNN model, we used elbow method for determining it. So here we can see that in 7 and 8 the slope is less slant. So from here we can decide that 7, either 7 or 8 will be our optimal K, and we used K in our recommended system. And for PCA also we plotted cumulative explained variance versus number of components, and there we got 9 as a value, optimal and components value. Then we also plotted our data into the clusters using TSNE and the PCA. For TSNE we used n components as 3, and for PCA we used n components as 8. So here you can see that data is more evenly spread in TC and TSNE, and mostly clustered and highly densely clustered in PCA. So here we did our some of the features analysis. Here all the values are scaled in the box plot. We can see that instrumental and loudness, pitchiness, and duration MS has some outliers. We will talk about it in the next slide. Second is a correlation matrix heat map. So this is our main feature analysis. Here we can see that mode feature only have two values, 0 and 1. Key distribution is not a feature which we will take into account, but we got it from the Spotify API. Instrumental have mainly 0 value among all the songs. Duration MIS have some peak values among 0. Rest of all the values are scaled except mode, key, and timeline year. So hence we only applied, so we dropped mode, key, instrumental less. And for the timeline of the music by release here, we can see that over here. Most of the songs are latest songs. So after applying all the previously described models, we found that our KNN, PCA, TSNE, these three techniques and these three algorithms will perform better. And we didn't have that relevant recommendation for comparing our result with. So we employed some user experience kind of thing to determine which recommendation will be cool enough. So that's how we decided which similarity metrics and which models will be good enough for this recommender system. So we employed 4 similarity metrics and 3 algorithms. So what we will do is we will give a song name to this model, and the model will return us recommendation provided by each of the following algorithms. And then a top recommendation songs list will be provided by using the counter method, which will decide which songs are more common in this all provided recommended songs list. Second is classifier. Hence, the Kaushik said that let GBM was performing well after doing the hyperparameter tuning. Accuracy has increased from 90% to 92.43%. So in the future work, we aim to improve our model, and first we will try to deploy, and we will try to create a user friendly platform like Spotify or YouTube Music for our users. So we can track many things from the users, such as user engagement, user satisfaction, or user clicks, number of clicks, etc., etc. This will help in improve our recommendation system. Or in the next stage, for improving the scalability, we can use the cloud solutions and distributed computing or parallel algorithms to distribute our workload over multiple servers or multiple cores of the CPU. In the conclusion, our music classifier have our best model as light GVM, which is top performing classifier amongst all. And for the music recommendation system, we included similarity metrics, which are this all four, and KNN clustering for clustering technique, PCA and TSNE for data reduction techniques. We used all of these, and we will provide a combined recommended songs playlist to our user according to what song name he provides to us. And this is the contribution. Thank you.
Hello, my name is Reganesh Tota and I am here to show how our recommender system works. Actually, to train the model, we need to run this command, but actually I have already trained the model, so we are going to skip this part. Now we will use the CLI to use the recommender. With this additional argument, we can give the file name, the song name which we want to recommend, like the song name which according to our recommender, the similar, it will give us the similar songs to that song. This is the song which I have chose, just so, and an argument of 10 for the PCA. When I run this, I would get the results. So after utilizing many of the frameworks like Euclidean distances, Manhattan distances, and all cosine distances, the songs selected by the system are, this is our original song and these are the recommended ones. Mujeres Divinas by Vincent Fernandez, We Will Rock You, and all those songs are recommended by our system. Thank you.
My name is Karan Reddy and I am going to explain how music classifier will be working. So when I run this command with the audio path, our code will divide the audio file into 3-second segments. For each of these 3-second segments, we'll extract unique features and determine their respective labels. Once we have extracted these labels, we will identify which label repeats the most across the segments. This dominant label will then be assigned as the label for the entire audio file. So now we can see that our classifier has classified this audio file as pop. Thank you.